Hello everybody, welcome back. Today we'll be looking at session 8. We want to learn how to access data in our database, and the session objectives for today are given below. We'll be learning how to use the select statement, its syntax and use. We'll explain the various clauses used with the select statement. We'll describe the use of the order by clause, describe working with typed and untyped XML. We'll explain the procedure to create, use, and view XML schemas. We'll explain the use of XQuery to access XML data. Okay, let's get started. Introduction. Now, the select statement is a core command used to access data in SQL Server, and XML allows developers to develop their own set of tags and makes it possible for other programs to understand these tags. XML is the preferred means for developers to store, format, and manage data on the web. Now, XML is a markup language, more or less like HTML. The main difference being that XML does not have a predefined set of tags, but HTML does. And XML basically allows you to exchange data between different systems. We look at this in the future modules we'll be covering. We'll look at this in the future modules we'll be covering later. Okay, we move on. Now, the select statement. A table with its data can be viewed using the select statement. You remember we did this in session 7. And the select statement retrieves rows and columns from one or more tables. The output of the select statement is another table called the result set. And the select statement also joins two tables or retrieves a subset of columns from one or more tables. This statement defines the columns to be used for the query, and the syntax of the select statement can consist of a series of expressions separated by commas. Now, each expression in the statement is a column in the result set, and the columns appear in the same sequence as the order of the expression in the SQL statement. Now, we have the simple syntax for the select statement given here. What you do is you type in select, then you give us the columns from which you would like to retrieve the data from. There can be several of them. You can see we are starting from column 1, going all the way to column N. Then you give us the table from which you'd like to get the data from. Now, many SQL versions use the from in their query, but in all versions from SQL Server 2005 upwards, one can use the select statement without using the from clause. In the following code snippet demonstrates the use of the select statement without using the from clause. We have this. Please highlight this. And I have a small assignment I would like you to do. Let me just display it in your query browser. Now we have this. This is what I want you to do. Let me zoom in. Open the Solution Explorer in SSMS. Then in the Solution Explorer, in the Queries tab, you create a new query. Then you give it this name. Please do that. Then let's continue. I've already done it. My query window is here. As usual, we're going to start by typing what it is we'll be covering in this particular session. Let's move on. I've written the purpose of this particular session. I've written the purpose of this particular session in line 1. Then this is what we want to do. We want to demonstrate the use of the select without the from statement. And the purpose of this query is to select the 5 letters in a word. And we highlight this and execute. And you can see it gives us the results down here. Now, this looks a bit weird, although that is what you're getting in your slides. If you look, okay, this is what we have. Now, we're going to learn something later, but I feel I need to introduce it at this particular juncture. This is not very meaningful, and you can change that by adding the as. As basically is used to create a column, alias or alias. Then you tell us what you'd like to call this. Now we're going to enclose this in square brackets, and we call this first 5 characters. first 5, sorry. Okay, then now we highlight this and we execute it. And you can see now it gives us first 5 characters. Now left is a function, and as you can see, it selects the first 5 characters. So this function accepts a string, and from that string, the number of characters you'd like to extract, starting from the left side. Now let's copy this very quickly. Copy, then come down here, Control V to paste. Now we want to select the last 5. Of course, you guessed that we would use the right function. So please, I'll pause the video here and make the changes. Do the same very quickly. As you can see here, I've already made the changes. I've changed here, we are selecting the 5 letters in a word. I've changed this and changed this as well. We highlight it, then we execute. And you can see that it gives us Asian as the last 5 characters in internationalization or international. Okay, US was international, so please just select that. We move on. Now, okay, before we move on, there's one more thing I'd like to show you here. You can also do some basic math. I'll pause the video, then type in what I want us to do. Feel free to go to the internet and look at some of the other things that you can do there. I'll highlight this all the way to the beginning, then execute this, and you can see now it gives us 25 as the sum of 23 plus 2. That is the work of the as statement. Basically, we're just giving a convenience or a name which is easier for us to understand. It doesn't always have to be in the database. Let's move on quickly. Now, we want to display all columns in the database, and this is something we did in brief in session 7. And if you remember, the asterisk is basically used in the select statements to get or retrieve all the columns from the table. And it is used as a shorthand to list all the column names in the table named in the from clause. The syntax for the selecting all the columns is given below. So select star from table. Now, table name is the name of the table from which the information is to be retrieved. And it's possible to include any number of tables. When 2 or more tables are used, the row of each table is mapped with rows of others. And this activity takes a lot of time if data in the tables is huge. Hence, it is recommended to use this syntax with a condition. So kindly note that. Now, the other drawback of writing the select star is you have a table like with millions and millions of records. Let's say it's the government database where we want to find out the number of citizens, and we do a select star. That would actually take up a lot of time. Think of something like the government of China. They have over 1 billion people, or India. That would actually take up a lot of your time and slow down your machine considerably. So if it's a small database, feel free to do this. But if it's a very large database, exercise some discretion or find out how you can do some optimization in that particular, how you can do some optimization in that particular query. We move on. Now, we have the following code snippet which demonstrates the use of the asterisks in the select statement. Use AdventureWorks, select star from human resources.employee. Now, you remember in session 6, I promised to show you how to install the AdventureWorks database. And at this particular juncture, I want to do that very quickly. Now, we are going to switch over to SQL Server Management Studio and install that database. I'll connect. Now, please make sure you connect as the admin so that you can assign people the relevant permissions in this. Type in your password, then click on connect. Now, to do this, you make sure you right click on the databases node, right click, then you select the option restore database. You need to navigate to the location where you stored that database. Now, in this window, that is the restore database window, you make sure this is selected. Sorry, not database. You make sure that the device is selected. We're actually restoring this from disk. Then after that, you click on the ellipsis button to open the select backup devices. You make sure you select file from this drop-down list. Click on the add button. This will open for you the Explorer where you're going to select where you saved that or where you downloaded that particular file. Mine is in D here. Then click on this. Now here's my AdventureWorks database. You click on it, click on OK, then OK, then click on OK. Give your computer some time, and ta-da, our database is restored successfully. We click on OK. Now, if I expand this, you can see I have the AdventureWorks database. I have two. This is the data warehouse. I'm not going to work with this. Our course is focusing on this AdventureWorks database. Now, we are going to grant people permissions. We click on properties. Then we come to permissions. Then, okay, we can grant public. So we want to assign the read permissions. So this is what we want to grant. We want to grant the select, just select grant. Now we don't want to grant insert. So feel free to look up these permissions. That is what we want to grant. Then I'm going to switch to my normal account. I don't want to use the system admin because you can make unwanted changes and it's not very good. So we click on OK. So I'm going to disconnect, then now log in using Windows Authentication. Connect, then Solution Explorer. Okay, let's open the solution. And yeah, we have this. Now, this is what you have in your, we change this to 2016 and we can execute this. Now, let's find out whether we have this particular schema. And something I would like to mention here. The structure of this particular table could be a bit different from what it is we have in AdventureWorks 2012. So kindly note that there are some changes which are going to be here and there, but I'll point them out as we go about this. It seems there are some permissions which I did not grant because you can see now I'm not able to list this. I'll have to switch back and make the necessary changes. So let me disconnect and switch over. Okay, we go back to AdventureWorks. Go back to properties. Then permissions. So we've granted the connect permission. No, we don't want to give that. References, select, then we click on OK. Now we can refresh this. I want to see if this particular table exists, that is employees. It's here. We can see we have the human resources schema, then the employee table. I'm going to switch over to the other account and see if I can access this. So I'll disconnect, come here, and use Windows authentication. Okay, databases, AdventureWorks, and that are good. Now we can access this data, and now we want to execute this statement so that we can use this database. Click on execute. We switch to this database. Then the next one is to display the data. Click on execute. And you can see we have the details displayed here. Now, the other way you can go about this is you use the fully qualified name. This means that if you're working in another database, if I go back to the master database or the CastDB, I can highlight this statement and click on execute. Once I click on execute, you notice it gives me the same result set. So it's basically a matter of choice the way you want to go about this. But now this one has a lot of typing. You have to start with the name of the database, then the name of the schema, then the name of the table. We move on. Now, here we're going to learn how to display data from columns that you select. You don't want to display now all the columns. You want to select a few of them. Now, the select statement displays or returns certain relevant columns that are chosen by the user or mentioned in the statement. To display specific columns, the knowledge of the relevant column names in the table is needed, and the syntax for selecting specific columns is given below. Now, this is select, then you specify columns which you want to display, and from the table. For example, to display the cost rates in various locations from the production, not location table in this database, the select statement is as shown in the following code snippet. Please highlight this, copy, and move and switch to the query window. Okay, all done. I'll highlight, then click on execute. Let me just check this. Now, there's something very important I forgot. If you look here, I'm executing the query in the wrong database. So let's switch to the correct database very quickly. Then now we can get the correct results. Okay, we have that. And I think we can remove this and it should still work. Although, let's have them to avoid that confusion of the keywords. Now, there's also something I would like to show you. Remember, we talked about the Microsoft SQL Server documentation site. I've already opened it in Firefox. You can see what we have here. I said you make sure the first thing you do is to select the correct version of SQL Server that you're using from this drop-down list here. And the left frame basically shows you the various topics that are covered in SQL Server. And from there, you can see I've expanded the queries node, gone down to select, and basically I'm looking at the syntax of the select statement. Now we will see all these. This is an elaborate coverage of the whole thing, and in our slides we are breaking it into bits. We'll see how to go about this. Let's move on very quickly. Using constants in result sets. Now, character string constants are used when character columns are joined, and they help in proper formatting or readability. And these constants are not specified as separate columns in the result set. It is more efficient for an application to build the constant values into the result set when they are displayed, rather than making use of the server to incorporate the constant values. For example, to include the full colon or the colon and this, in the result set so as to display the country name, the region the country region code and its corresponding group. The select statement shown in the following code snippet is used. We highlight this, then switch to the query window. Okay, we have this. Let me unpin this. The comment, we want to format the data in a result set using constants. Make sure you are executing this in the correct database. Then click on execute. And you can see now we build the data, or we build these characters into the result set. So that is how we go about this. We'll move on. Renaming result set column names. Now, this is what I was talking about. When columns are displayed in the result set, they come with corresponding headings specified in the table. And these headings can be changed, renamed, or can be assigned a new name using the as clause. Therefore, by customizing the headings, they become more understandable and meaningful. And the following code snippet demonstrates how to display changed date as the heading for modified date in the DBO individual table. The select statement is given here. We have this, and we don't have this table, so I think we can pass over this, although we did this when we started. Now, computing values in the result set. A select statement can contain mathematical expressions by applying operators to one or more columns, and it allows a result set to contain values that do not exist in the base table, but which are calculated from values stored in that particular table. An example, consider the production schema product cost history table from the AdventureWorks database. Consider the statement where the production people decide to give a 15% discount on the standard cost of all the products. Now, the discount amount does not exist, but can be calculated by executing the select statement as given here. Highlight this, copy, and switch to the query window. Okay, we have the query, we'll highlight it, then execute, and you can see what it is that we have here. Now, you can add an alias so that this makes sense. As then highlight and execute. Okay, we have that. Now, we want to do something. Let me just pause and give you a small challenge. Then we continue. Okay, we have this. We want to rewrite the above query to display the product ID, the standard cost, the discount amount, and discounted price. Make sure you add the proper column headings. And for each of the monetary columns, that is for standard cost, discount amount, and the discounted price, you make sure you display the results correct to 2 decimal places. Please find out how to go about this from the internet, then we continue. This is the expected solution. I'm not going to show you what to do, but once you execute this query, this is what you're supposed to get. Notice now all the columns, the data is displayed correct to 2 decimal places. We move on. Now, using distinct. Now, the keyword distinct prevents the retrieval of duplicate records, and it eliminates rows that are repeating from the result set of a select statement. For example, if the standard cost column is selected without using the distinct keyword, it will display all the standard costs present in the particular table. But once you use the distinct keyword in the query, SQL Server will display every record of the standard cost only once as shown in the following code snippet. Please highlight this, copy, and switch to the query. We highlight, then execute, and you can see the unique standard costs. We move on. We have the top and percent. Now, the top keyword will display only the first few set of rows as a result set, and the set of rows is either limited to either a number, either you want the top 5, top 10, or whatever it is that you specify. And the top expression can also be used with other statements such as the insert, update, and delete. The syntax for the top keyword is given below. select either all or distinct, then top either percent, or you can use top 20%. This is optional, and then with ties. Now, this is what I want to explain. With the ties is the additional numbers of rows that is supposed to be displayed. Let's see if we can get an example very quickly. Just one moment. Now, you can see the purpose of this query. We want to obtain the top most 5 expensive products. This is product cost, standard cost, from the product cost history table. Now we're going to highlight this, then click on execute, and you can see what it gives us. And this is in descending order. Now you can also use a percentage. So if then highlight and execute, so it gives us the top 5% standard cost from the production.product cost history. So I'll take this back to what it was. So please remove this, and these are the details. These are the results that we get, and we move on. Now we have the select into. Now the into clause basically creates a new table and inserts rows and columns listed in the select statement into it. The into clause also inserts existing rows into the new table. In order to execute this clause with the select statement, the user must have the permission to create table in the destination database. Now this means you're not going to execute this in the AdventureWorks database. We're actually going to get these records and insert them into our cast DB. The syntax is given here. Select, then the columns which you'd like to select, then into the name of the table which you want to create, and then you select the table which you want to retrieve these columns from. We have this statement here, and this is what it's going to do. The following code snippet uses an into clause which creates a new table, production.product name, with details such as the product ID and its name from the production.product model. Now highlight this, then switch over to the query window. Change your query to look like what I have in my query window. Now pause the video here and make the relevant changes. After that, what we want to do is to confirm whether we have this table in our database. So currently we have the bodies table, the cellular phone. These are the tables we have. We don't have a product name table. So we want to execute this query and confirm whether this table will be created here. Highlight, then click on execute, and you can see 128 rows affected, meaning it has created this table and inserted 128 records. I'll refresh, click on tables, then refresh, and we have this table, and you can see the details. You can right click and display the details. Remember what we said. Here are the columns which have been created in this particular table. We move on. Now select with the where. Now the where clause with the select statement is used to conditionally select or to limit the records which are to be displayed or to be retrieved by the query. A where clause specifies a Boolean expression to test the rows returned by the query. The row is returned if the expression is true and discarded if it is false, and the syntax for this statement is given below. So select column 1 all the way up to column n. You specify the table, and basically you give us the where clause. Now where the search condition, this is the condition that is to be met by the rows which are to be returned in the result set. And the following table shows the different operators which can be used with the where clause. This is used for equality. This is not equal to, this is greater than, less than, greater than or equal to, less than or equal to, this is not. We have between, between a range, like, and in. We had discussed this earlier, that is why I'm going through them very quickly. And the following code snippet demonstrates the equal to operator with the where clause to display data with the end date of this. So please highlight this and let's get the details. Okay, we are going to highlight this and execute. And we have a small problem here. This is what I was telling you. Some of these queries may not execute because some of these dates may have been changed from the previous version to this new version of 2016. Let me just check, then I'll modify my query and we can take it from there. Okay, please change your query to look like mine. Execute it and you should get these results. Let's move on. Now, all queries in SQL use single quotes to enclose text values. For example, consider the following query, which retrieves all the records from the person.address table, having Bordel as the city, and the following code snippet demonstrates the equal to operator with the where clause to display data with the address having Bordel city. Please highlight this and execute it. Okay, we highlight and execute. And we can see these are the people coming from Bordel. This is the column of interest. We move on. Now, numeric values are not enclosed within any quotes as shown in the following code snippet. Please highlight, then copy and switch to the query window. Now, here we are fetching or retrieving all the details of departments with an ID less than 10. Highlight, execute, and this is what we get. We move on. Now, the where clause can also be used with wildcard characters as shown in the following table. Now, we have this table. The first column represents the wildcard, its description, and we have an example. We have the underscore. Now, it will display a single character. So, select star from person dot contact where suffix like JR, then one letter after JR. The next one is the percentage. Now, this one will display a string of any length. Select star from person.contact where last name like B. This one is displaying the people whose name starts with B. Then we have the brackets. This will display a single character within the range enclosed in the brackets. So select star from sales.currency rate where to currency code like. So this will be CAN, then DY. So it can be CAD or CAY or CND or CNY. Now, this one is used for negation, so it will display any single character not within the range enclosed in the bracket. So select star from sales.currency rate where to currency code like A, not R, then not S. So any letter apart from R and any letter apart from S. Now all wildcard characters are used along with the like keyword to make the query accurate and specific. So the where clause also uses logical operators such as the and or a not, and these operators are used with such conditions in the where clause. The AND operator joins two or more conditions and returns true only when both the conditions are true. You remember this from your programming classes. So it returns all the rows from the table where both conditions that are listed are true. And we have a small code snippet here that makes use of the AND operator. Now, as you can see here, I've pasted these details or these queries just below the other one we had, the one which was returning ID less than 10. Now, the first one is going to display all the details of individuals whose suffix starts with JR followed by a single character. Now, what I'd like you to do is you can go and sit down and look at that database in detail to get and see all the tables which are there. And there are quite a number of examples on how to use the AdventureWorks database online. So feel free to look at some of those sites which use that particular database. I'll highlight this very quickly we can execute that and you can see the results it gives us. Then the next one is display business entity ID and names of individuals whose last name starts with letter B. Highlight this, then click on execute, and we get this particular result. Now the reason why I'm doing this is that you really need to practice some of these things so that you are quite comfortable with them. We can't show you everything with the time we have here in class, so feel free to do a lot of practice with these queries. This knowledge, as I said, is very essential in your Java classes, in your C# classes, in your in your PHP classes. So please feel free to do a lot of practice. We move on. Now we have the OR operator, and this returns true and displays all the rows if it satisfies any one of the following conditions. So the following code snippet demonstrates the use of the OR operator. So highlight this, copy and switch to the query window. Okay, I've pasted mine at the bottom here. We move on, highlight this, then execute. And you can see what it does. Then the query will display all the rows whose address ID is less than 900 or whose address type ID is equal to 5. The NOT operator basically negates the search condition, and the following code snippet demonstrates the use of the NOT operator. Highlight this, copy, switch to the query window. Okay, we highlight this and execute it. We get this. Now you can also use, this is the other way we write the NOT. I'll show you here very quickly. We do that. We remove this. This actually now gives us. So we have this number of rows, and I'll take it back to what it was and we compare and see whether we are getting the same results. Equal, then this is NOT. Highlight, execute, and we get the same results. Okay, now the code will display all records whose address type ID is not equal to 5, and multiple logical operators in a single statement can be used. Now, when more than one logical operator is used, NOT is evaluated first. You remember this from your session 5, then AND, and finally the OR statement. The group by clause. Now, this clause partitions the result set into one or more subsets, and each subset has values and expressions in the column. Now, what we're saying here is, I would like to find out the students who are maybe enrolled in art. We want to find out those who are pursuing computer science. We want to find out those who are pursuing education. That is, now we can group them by courses. That is what we are calling this partition. Now, if an aggregate function is used in the group by clause, the result set produces a single value per aggregate, and every grouped column restricts the number of rows of the result set. For every grouped column, there is only one row. The group by clause can have more than one grouped column, and the syntax for the group by clause is given below. We have the select statement, the columns, then the table from where you'd like to get these details, then we specify the column which you want to group by. Now, we have this example here. Consider that if the total number of the resource hours has to be found for each work order, the query in the following code snippet would retrieve the result set. So let's highlight this, copy, and switch over to the query window. We're going to highlight this and execute it, and you can see the results displayed down here. There's one more I'd like to show you. Now we have this query, and its work is just to get for us the various groupings of the address type IDs. this is the query that you're going to type in, highlight it, then click on execute, and you can see we only have 3 of them. So we have 2, 3, and 5. This is that example illustrating of like you want to find out the courses which students are pursuing. It would maybe give you like art and so on and so on. We continue. Clauses and statements. Now, Microsoft SQL Server provides an enhanced query syntax element for more powerful data access and processing. We have the common table expression in select and insert statements. Now, a common table expression is a named temporary result set based on a regular select and insert query. And the following table demonstrates the use of the common table expression in the insert statement. Now, we are going to highlight this and copy, and this is the expected result. So please highlight this, copy, and switch to the query window. Okay, I've pasted and made a few changes just for readability sake. You can still have it the way it is typed in the slides. Then it goes all the way up to this particular point. Now you have to highlight from the beginning all the way up to the end here. Then click on execute. And we have this small hiccup. I forgot about this. Let me just switch over to the other database. Now we switch to the cast DB. You notice the selection is still valid. Then click on execute, and you can see what it does for us. So you have to highlight this as a single statement, and that is what it gives us. Okay, you can compare the result set with what we have in your slide. Now, the output clause in the insert and update statement, the output clause returns information about rows affected by an insert statement and an update statement. And the following code snippet demonstrates how to use the update statement with an insert statement. Highlight from this slide all the way up to here, then copy and switch over to the query window. Once you highlight this is the, and execute it, this is the expected result. Okay. Now, use the output clause to display the rows affected by batch statements. So there is a word of caution here. We need to execute the statements below as one batch to avoid errors. So we highlight starting from here all the way to the bottom down here. This is the last statement. So this is the query we are going to execute, and make sure you're executing it in the cast DB. Click on execute, and you get this result. Now, each of these is well commented what exactly is happening. Okay. So make sure you read in the comments. We move on. We have the .write clause, and this is used in an update statement to replace the value in a column having large value data type. And the syntax for the .write clause is given below. So .write, then expression, offset. Offset basically is where we want the replacement to be done. Then length is the length of the portion in the column starting from offset that we want to replace. If it is like a sentence, we might want to change a few words in that sentence, or maybe so many characters after that. Let's see a practical example. Please highlight this and switch to the query window. We are going to see this as the result. Okay, finished. Now, I've not saved my code so that you can see what it is that we have changed. So this is the comment illustrating what it is that we want to do here. I'm going to highlight everything from line 180 all the way to 196. Click on the execute button and you can see what it gives us. So we actually changed 3 rows and the results are actually given down here. Okay, we move on. Order by clause. Now the order by clause specifies the order in which the columns should be sorted in a result set. Order by is used to arrange your columns. Now it sorts the query results by one or more columns, and a sort can either be in ascending starting from the least or descending starting from the highest. And by default, records are sorted in ascending order. To switch the descending mode, you will use the optional keyword desk. So when multiple fields are used, SQL Server considers the leftmost field as the primary level of sort and others as lower levels of sort. The syntax is given here. Select then columns which you wish to display, the table from which you wish to retrieve these results from. Then you specify which column you want to use to sort this. And you don't have to write ascending. We've seen that this is the default order. Okay. And if you want now, this is what you usually type. We have an example here. So this is going to display. So this statement in the following code snippet sorts the query results on the sales last year column of the sales.sales territory table. So please highlight this, copy, and switch over to the query window. Now, this is what I'm going to execute. I've just written the fully qualified name because I'm still in the customer database. We highlight this, then we execute, and we actually get the results. Notice it's starting from, it's in ascending order, and we are ordering by sales last year. So this is the least sales, and this is the highest sales in this particular column. Let's move on. Working with XML. Now, XML, that is extensible markup language, allows developers to develop their own set of tags and makes it possible for other programs to understand these tags. XML is the preferred means for developers to store, format, and manage data on the web. Applications of today have a mix of technologies such as ASP, Microsoft.NET technologies, XML, and SQL Server basically is working in tandem. Now, in such a scenario, it is better to store XML data within SQL Server. Now, native XML databases in XML 2012 have a number of advantages, and some of them are given below. We have easy data search and management. So all the XML data is stored locally in one place, thus making it easier to search and manage. Better performance. Queries from a well-implemented XML database are faster than queries over documents stored in a file system. Also, the database essentially passes each document when storing it, and we have easy data processing. Large documents can be processed easily. Now, SQL Server supports native storage of XML data by using the XML data type. Now, let's look at the XML data type. In addition to regular commonly used data types, which we looked at in session 5, SQL Server provides a brand new type in the form of XML data type. And the XML data type is used to store XML documents and fragments in an SQL Server database. An XML fragment is an XML instance with the top level element missing from its structure. The top level element is like the HTML in HTML document. And the syntax to create a table with columns of type XML is given below. So create table, then the table name, then the column list, column name, XML, then the other columns. Now, the following code snippet creates a new table named phone billing with one of the columns belonging to XML data type. Now, we're not going to do this in the AdventureWorks. We're actually going to do this in our CartDB. So highlight this and then copy and switch to the query window. Okay, Now, you notice here we have a schema called person, and that is why I've written this create schema person. It's underlined, and this is essentially because, as you can see, the tip which you're getting here, this statement must be the only statement in the batch, but that should not worry us. The next thing is to then go ahead and create this inside this schema. So I'll start by highlighting this statement, then click on execute. After that, we then go ahead and create this table. And kindly notice we are doing this in our CastDB database. We click on execute and the table is created. Confirm this from your Object Explorer. We go to the CastDB. I'll refresh the tables. And basically now you can see we have the person schema and the phone billing table. We move on. Now, a column of type XML can be added to a table at the time of creation or after its creation, and the XML data type columns support default values as well as the not null constraint. Now, data can be inserted into the XML column in the person.phone billing table as shown in the following code snippet. Okay, now in this code snippet, we're not going to highlight the use statement since we'll be inserting this in our person phone billing in our database, in the customer database. We're going to highlight from here all the way to the bottom, then execute it, and this is the expected result. So please do that very quickly. Okay, all done. Let me save my work. So we highlight this query and execute it, and you can see what it gives you. You can double click here or drag so that it gives you all the details that you have inserted into this particular table. Okay, typed and untyped XML. Now, there are two ways that you can store XML documents in the XML data columns, namely either typed or untyped XML. And an XML instance which has a schema associated with it is called typed XML instance. And a schema is a header from an XML instance or document. It describes the structure and limits the contents of XML documents by associating XML data type with its XML element, types, and attributes. Associating XML schemas with XML instances or document is recommended because data can be validated while it is being stored into the XML data type column. SQL Server does not perform any validation for data entered in the XML column. However, it ensures that the data which is stored is well formed. We'll understand what this is when we are covering XML. Now, untyped XML can be created and stored in either table columns or variables depending upon the need and scope of the data. So the first in using typed XML is registering a schema. This is done by using the create XML schema collection statement as shown in the following code snippet. Kindly copy this. Don't copy the use sample DB. We are going to do this in the CastDB. We'll copy from here all the way to this particular spot. So do that, then let's meet in the query window. Now make sure you type it correctly. There is this quote, and this is opened here and closed at the bottom. Then we are going to execute it. Okay. Save your work. We continue. Now the create XML schema collection statement creates a collection of schemas, any of which can be used to validate typed XML data with the name of the collection. This example shows a new schema called Cricket Schema collection being added to sample DB. Once a schema is registered, the schema can be used in new instances of the XML data type. Now, the following code snippet creates a table with an XML type column and specifies the schema for the column. Now, we are going to continue, highlight this, don't select the use statement, then copy and switch over to the query window. Okay, then highlight, execute this, we go back. Now, to create new rows with typed XML data, the insert statement can be used as shown in the following code snippet. And a typed XML variable can also be created by specifying the schema collection name as shown in the following code snippet. Now, highlight these two statements and copy them into the query window. Kindly omit the use sample DB. We're actually using the customer DB. Now, I've copied this and pasted, made a few edits. Okay. Now, we are going to highlight this and execute. You can execute them at once. I'll do that. And you can see the details displayed here. Now, we move on to XQuery. Now, here we are going to have a high-level overview of XQuery, and we'll look at this later on when we are covering the XML and JSON unit. So, if you really don't understand what exactly is going on here, just bear. For now, we'll look at this as we cover XML and JSON. Now, XQuery. After XML data has been stored using the XML data type, it can be queried and retrieved using a language named XQuery. XML query, that is in full, or XQuery, is a new query language that combines the syntax of relational database and XPath language, and it can be used to query structured or semi-structured XML data. To query an XML instance stored in a variable or column of XML type, XML data type methods are used. Developers need to query XML documents, and this involves transforming XML documents in the required format. Now, XML makes it possible to perform complex queries against an XML data source over the web. Some of the XML data type methods used with XQuery are described as follows. We have the exist. Now, this method is used to determine if one or more specified nodes are present in the XML document. And this function basically returns 1 if the XQuery expression returned at least one node, 0 if the query expression evaluated to an empty result, and null if the XML data type instance against which the query was executed is null. The following code snippet demonstrates the use of the exist method. Now, we are going to query this against what it is that we entered. Highlight from here all the way to here, copy and switch over to the query window. Now, we highlight this query and execute it, and we get the results displayed here. Now we have this. Then we have the query. Now, this method can be used to retrieve either the entire contents of an XML document or a select section of the XML document. And the following code snippet shows the use of the query method. We highlight from here all the way up to here. So do that very quickly, copy, and let's meet in the query window. Okay, we have this. We highlight and execute this, and we get the results displayed here. Then finally, the value method. Now, this is used to extract scalar values from an XML data type, and the following code snippet demonstrates the use of the value method. We highlight this, copy, and switch over to the query window. So we highlight this, then execute, and we get the results here. Now, we forgot something very important. We didn't explain what it is that we were doing. Here we want to demonstrate the use of the exist method. Now highlight this and copy, paste. Here we change this to query, and the last one to value. Then now you can save your work. Now we are through with this session. Let's summarize very quickly. Now, the select statement retrieves rows and columns from tables. Select statement allows the user to specify different expressions in order to view the result set in an ordered manner. A select statement can contain mathematical expressions by applying operators to one or more columns. The keyword distinct prevents the retrieval of duplicate records. XML allows developers to develop their own set of tags and makes it possible for other programs to understand these tags. A typed XML instance is an XML instance which has a schema associated with it. An XML data can be queried and retrieved using XQuery language. Now, thank you, God bless, and let's meet in the next session.